Hello. Today is April 8th, 2025. This is week after KubeCon. Welcome everybody to SIG Node weekly meeting. We have a few items on agenda. First is from Bing, but I don't see you. Is anybody here to present these items about event flag and container statuses? Okay. If this is the case, we go to the next item. Kevin?
Hey, could I get a presenter?
Sorry for that. Can I get presenter right, please?
Just give it to you.
Thank you. Okay, good. So basically, I have those two things to talk about, and both are related to pod level resources, the feature with which Dixie is driving. The first one is related to huge pages. Basically, we have had some discussion, and we are wondering if, in the case that the user is using pod level resources, if we should allow the aggregated values of the huge page request and limits to be greater than pod level request and limits when they are being when pod level huge pages are being used. The considerations for this and the important things to have in mind is that currently huge pages are handled as a not overcommittable resource, so the request and limit must be equal all the time. Basically, the limit always must be specified, while the request can be optional, since we will actually rely on the limit. For the C group, we don't have any controller that we can map to for the request. So basically, Kubernetes just maps the value to the C group, and it kind of behaves as a hard limit that it's handled like for certain access to the corresponding containers, but we don't have like a minimal request if we don't set, if the container sets a bigger value than its request, like for its needed for huge pages, for pod level resources. Basically, the container is able to use the whole amount, even if it has also been requested by another container, and basically the whole resource became shared between all the containers. And that would be the thing. And we wanted to know what would you think about it. And one example, to put it simple, is that currently, if the user sets request huge pages at container level, they can set like 50 megabytes and then 70 megabytes for two containers, and the aggregated value, the total value in the pod, would be the sum of those. But we're wondering if it would be possible to set the container level values to be bigger than the pod level request. And at least personally, I think that it shouldn't be allowed because it would present inconsistency between the container level and the pod level. So it would basically break the non-overcommittable treatment that we are currently giving to huge pages in Kubernetes. And kind of similar behavior can be obtained just by not defining the resource and just defining a limit at the pod level. The only thing is that the advantages would be to actually you would be able to cap the containers like at different sizes be inside the pod when using pod level resources, and it basically allows you to have bigger customization. But it will basically it. And another thing to keep in mind that for pod level resources, the secret values for the containers, the aggregated value, would be actually bigger than the pod level limit. So that way the containers can share the resources within the pod.
I don't know if anybody has comments. Let me start with a simple question. Pod level resources, I remember we started with requests and limits for CPU and memory. now it's talking about extending to huge pages, so it was already extended for huge pages and we have a problem. I just don't remember the latest state.
But it's
One
also
PR related to huge pages has been already released to the previous minor, and right now this will be just like a new consideration if we should allow this case.
It was historically some tricks what Kubernetes was doing related to the huge pages on the pod level. So because huge pages can be consumed in two ways, like as a normal resource or using the TLBFS. And because of the TLBFS, the actual like multi-container request of one of the huge pages was enforced by the kubelet as a sum of all container requests and put it into a pod SIG group. So we might see just the consequences what like two code passes are changing the same value.
Isn't that the same for memory and CPU? Like the pod level C groups are being set by kubelet even today. It just
Well,
aggregates the container level values and sets those as the pod level values.
yes, and that was done when we implemented the pod level resources. But for huge pages, it was a special bit of a code inside kubelet, which was calculating the group level, like the pod level resources separately. So we just need probably to check what those two pieces are not conflicting together.
Okay. Okay. I think, Kevin, could you please go to slide number 3? Yeah, so I think we are trying to get a consensus, or rather, we are trying to communicate how we want or how we think huge pages could behave with pod level resources. So, with pod level resources, the idea is multiple containers inside the pod should be able to share the resources amongst each other depending on the usage. Like if container 1 is not using that resource at a time, container 2 should be able to use the unused resources. So for this case, with memory, um, this case is allowed where you set pod level values as 100 megabyte, and then container level aggregated container level values are greater than the pod level limits. So we are saying that for huge pages, this is something that we might not be able to support. And if there are containers that want to share the resources, then they should just set pod level values and just completely ignore setting container level values to support the same use case. So we are trying to communicate that huge pages will behave differently than memory, and to support the use case as shown in this slide, only the user will have to, or the user should set only pod level values, and setting container level aggregates greater than pod level values will not be supported in huge pages with huge pages. So I want to hear if anyone has other thoughts here. And the reason for this is, since huge pages cannot be overcommitted, it requires today at container level to set request equal to limit, and we want to continue the same behavior for pod level resources. We do not want to support overcommitting ideally at pod level with pod level resources. But within inside the pod, how the containers are consuming huge pages is something that this pod wouldn't care about if pod level resources are set.
Why you are saying what those cannot be overcommitted? So the huge pages doesn't have limitations. What like limits should be equal to requests.
Uh, I mean, today that is a limitation in Kubernetes. And I thought that this was decided on before because huge pages are allocated once the node boots up, right? And that cannot be changed. But please correct me if I'm wrong. So the problem is, or rather, the decision is coming from the existing fact that requests have to be equal to limits for containers if they want to allocate huge pages. This
No,
is
it shouldn't be the case. I mean, like discovery of amount of huge pages available on the node, yes, it's done only once when the kubelet is starting. But from the API perspective, from C group's perspective, like huge pages is just like consumable resource. So like you can request minimum or request zero, but you have only limit control, like the maximum amount of huge pages.
Okay. So I think in that case, my question is anyone aware of why it was decided to set request equal to limits for huge pages at container level in Kubernetes today? I'm sure that at least this part is correct because that's how it behaves today. If I were to create a container with requests lower than the limits for huge pages, there is a validation error that comes across. So, does anyone know why that was decided for huge pages?
It's actually strange. I don't remember what validation error in the past, but I might be wrong.
Okay, I
Was-
mean, I can share a couple of links after the meeting and we can rediscuss this. But yeah, just wanted to bring this to attention that if this is what we are doing at container level, we might have to um, support the same thing at the pod level as well.
Yeah, currently, huge pages are treated as non-overcommittable resources, which basically has some validation that forces you to define the limit and the request to be equal, and the limit must be always be present.
I've shared the link on chat as well and adding it to the notes, which clearly says that huge pages requests must be equal to limits. Yeah, we can discuss this again in the next meeting to have a consensus. But I just wanted to bring this up so that people are aware, and then we can search the code and get back again in the next meeting.
Yeah. Besides API usefulness, can we look at use cases like what people may actually do with that and what they will want with that? Because I don't know, like we can decide some consistency, but it may not work for some use cases. So maybe we can start with actual usage.
Yeah, so that's why we thought that we can start with setting only pod level values or rather, like the specific case that Kevin mentioned in the slide. Um, if we wanted to support that, then we'll have to add restrictions or rather remove restrictions from the validation. So we could start with a restricted value and then ease up the validation later if there are users wanting to use that, if there are users who would need this use case. Do you think that would be valid, or should we think of all the use cases and then decide the validation logic?
Maybe look at use cases, like what
Yeah.
kind of huge page what kind of usages people will have for this, and like whether they will need to share it. Anyway, can you also explain why this is part of pod level resources cap? Is it like pod level resources cap, or it's another pod level resource that you want to look at while you're doing cap on pod level resources?
So the idea is to support CPU memory and huge pages as a part of pod level resources. So this is part of pod level resources cap.
I see. Any other resources that will be included?
No,
Okay.
not to begin with.
Okay. Any more questions from a group? Okay, next topic is also Kevin, right?
Yeah, well, one last thing for huge pages. Currently, even though we are setting the container limits in the code for huge pages, since containerd currently has the huge TLB controller disabled by default, the user will basically see their containers. If the user deploys multiple containers in the same pod, and both containers or any more containers than one use huge pages, the behavior that the user will see is that because of having the huge TLB controller disabled, the containers will be able to access the whole huge page amount within the whole huge page amount, including the huge pages belonging to other containers. So that would basically allow any container who requested first or allocates first to basically monopolize the whole huge page resources within the pod. And yeah, that's just another thing that I wanted to mention, that because it is inconsistent with the current documentation that we have that mentions that basically because of not being overcommittable, the user would be expecting like guaranteed huge pages for each container. But if the user deploys more than one container, basically the resource will be shared within all the containers, and one container could monopolize the whole resource. For the second subject, this is related to the limit ranger. And in this case, there has been some discussion about if the default request for pod level should be applied the same way as the container level is being applied today. And well, this discussion initially it's currently in the PR. I can share it right here. And basically, what is being discussed is if the setting of those defaults should be different when the container defaults are present in the limit ranger, because the user might have some situations where doesn't want to have the pod level resources applied if it's already being set at container level, which for some cases it makes sense. Like putting an example, having multiple containers and all the defaults for container level would be applied to those containers, and in those cases the pod level resource would basically become irrelevant because the containers already will have the default and default request, and that would basically make some unnecessary changes to the pod spec, and also the possibility of wasting resources. But the thing for that is that since this is a property that the user can customize and can define, it wouldn't have any need to actually, well, I think that there wouldn't be any worry about it, because if the user is already setting the default request for pod level and container level, the user should already be like having and be conscious about what the change what that limit range is going to cause within the cluster. And one thing that I'm against because of not setting because of but the point is the question is to set to have the same behavior between container level or pod level when setting the default and default request. And one of the considerations is that currently the limit range doesn't check for any consistency. So it is possible to actually generate an unscalable pod because of applying default request smaller or bigger than than the current request limits. So this will basically, currently, basically the user is able to create a limit ranger that generates unscalable pods because depending of the pod spec that they are trying to deploy. Basically, there's the responsibility of the user to configure it properly. And one thing that I'm against of not setting, of not having the same behavior for both levels is that what would happen if the user has multiple containers and one container of them has already limits, and all of the other containers would basically have not set the request and limit. So that would allow for one container to be constrained to the limits specified, and all the other containers would basically depend on the default limit and request that is set in because of the limit range at the pod level. And in the case, the other one that I talk about, when having just containers that already have the request defined, the request and limit defined, and it can be one or more. Actually setting the pod request would not make any sense because the aggregated value of the containers would already cover for that aspect. However, if we don't set, we don't have the same behavior for container and pod level, and if we don't set the values the same way, this case where we have a container that specifies and others that doesn't specify would be basically not possible and would constrain the usage of pod level resources with the limit ranger, which it's not desirable. Basically, the disadvantages would be just that the user would have more complexity to consider while deploying the limit range and their pods. And the advantages would be that basically the users can continue specifying different namespaces if they want different behaviors or different applications for the limit range, so they don't apply to every pod that they create in the cluster. Basically allows the case that some containers specify and some don't, so the pod level can take the precedence over that resource if defined in the limit ranger and pod level resources are enabled. So basically the objective of this is to start a discussion about what do you think if the behavior should be different as it is proposed in this comment, or basically if the user set container and pod level defaults to be set normally as they would be currently for a container level without having any difference or precedence.
My position here is, I mean, this cap is very much about writing tables, like what will happen in this situation, and like combination of what is set on, in this case, range limiter and what was set on a pod. So we need to look at all the different combinations, but there are a few considerations that we need to make sure we follow. First is people who set in limit ranger, they expect some I mean, they do it for purpose, right? So typically they want to limit how much resources people can use, or maybe different purpose, but like most commonly, and thing I worry about is people like limited their usage of resources by pods. And my worry is that if we change the logic of this pod limiters, and people like users of this Kubernetes cluster may override what was the intention of limit ranger. So limit ranger was said like you can't use more than X, and then like we changed the logic, and now people can schedule pods with pod level limit and work around those limitations that limit ranger was expected to set. So it's kind of breaking breaking on upgrade. We can say that it's okay, and we will just publish release notes, and everybody using limit ranger for this purpose will need to adapt and change what they do. Um, but maybe we need to like do it better somehow. Anyway, I think most importantly here is to understand what limit ranger is used for, and make sure that people will still be able to express what they expressed before, and then people will be able to um, I mean, we wouldn't get in a situation when people expect that they have their cluster protected, and then with upgrade, users can work around those limitations. But it's really hard to think on the fly, like what's the right approach here. It really needs to have the stable, like what is expected, what the situation, what the behavior will be.
Yes, the main thing would be to decide, because it can change after this feature has been implemented, but it will have to decide if we want to allow from the beginning and then constrain it. That it would, I think it would be worse, and or start more constrained and then allow the full definition of, well, the treatment of both levels to be equal. However, for taking into account like the use cases, probably the user will not use both levels at the same time normally, and it would be just setting at pod level or container level depending on what they have, but they can still have the possibility of using both at levels in the same limit range if they want to. So we don't constrain from the beginning and allow the user for have any kind of personalization in regards to this.
I think we are discussing two problems around limit ranger. So, Sergey, what you mentioned, I think we still haven't thought about how we would address that one. Like, if there are existing container level limit ranger with whatever default, for whatever limits that are set there, and then the user will be able to get away with that by just setting pod level values. So, I think we haven't gotten to that problem yet. These We are discussing about the second problem here, which is so on the PR that Kevin sent, um, so today pod level limit ranger doesn't allow setting default request and limit. And the reason for that is because we did not have anything like requests and limits at the pod level, right? But with pod level resources, we think that we should be able to support that. But on the PR, what Tim said was, what if the pod level limit ranger and the container level limit ranger are not consistent? What happens then? And what happens if there are existing pods and then the customer sets, the user starts using pod level limit ranger on top of it? So will the existing pods, if they were to be rescheduled, will they become unschedulable? So he had two concerns around that. So for the first one, um, about the inconsistency, we saw that even for the existing container level limit ranger, the documentation says that the consistency is on the user, and the user is supposed to make sure that the containers that they create abide by whatever container level limit ranger specifies. And even in that case, it's possible to get unschedulable pods. So this was my argument, and we eventually got to the consensus there as well. But I want to hear the thoughts from this room as well. We wanted to say that even if the user sets both container level and pod level limit ranger, it's on the user to make sure that their pods are consistent with whatever limits they have set in the limit ranger. And for the existing pods, since this is a new feature, to it will require to make sure that the existing pods are not affected, it's advisable for the user to set pod level limit ranger in a new for pods in a new namespace and not in the existing namespace. So these were the two thoughts to answer Tim's questions there. But yeah, I would also love to hear what people think here. And like I said, we can get back to this again in the next meeting because this is a lot of information. So people can digest the information. Maybe we can add a one-pager doc and share it in the notes today or tomorrow, and then people can digest the information and we can discuss it again in the next meeting as well.
Yeah, some summary document will definitely be useful. But what you said about use cases, and I mean, what I'm saying about use cases and how people, like, if they have existing limit rangers and they don't need to be, they shouldn't be broken by that because they have an expectation. So I think we need to start with expectations, what you want to achieve here. So if you say we want to introduce limit ranger for pod level resources, do we expect that all people will only use pod level resources now, or do we expect that they will configure both? And if they will configure both, I don't think the API as proposed would work just fine, because you never know how many containers are inside your limit ranger. So it's almost impossible to write a limit ranger that will not break containers most of the time. So maybe API needs to be changed. Maybe it's not like about like constants, maybe like per container, or like total, or like max off, or some other APIs that we can introduce to make sure that we can express use case that customer can achieve. So that's why I'm asking about use case. Like, what do you want to achieve in the use case when you specify pod level limit ranger, like pod level limits or pod level defaults?
Yeah, we can write a doc with that use case and then get back on this. But yeah, even with the existing container level values, it's still possible for user to try creating inconsistent pods, and then the scheduler would just reject those pods.
And this is fine. It's old API, and like I put this note there because we saw this question being asked all over again, and we didn't want to change this old object that some people are already using. So maybe new objects that we introduce with pod level resources needs to be designed a little bit differently. Maybe we don't even need this functionality for pod level resources. We just need to make sure we're not breaking anybody.
Yeah. So I think we wanted to reuse the existing pod object, limit ranger of type pod object. This would just introduce two new fields, or rather, yeah, those fields are already there. Those are just rejected by the validation logic that do not allow setting default requests and limits for type pod limit ranger. So we wanted to just open that validation, and those are not mandatory fields as well, so it wouldn't break the user. And since this is a new field that will be these are the new fields that will be supported, I don't think it will break the existing stuff, right? Like the user will have to go and set those values specifically, and only then those values will be added to the limit ranger. So this is my argument. I don't think it would break the existing stuff. The user will have to add and set those values, and only then those limit ranger at pod level will be applied.
Yes, it will not break any existing limit ranges. Basically, this question is for the coexistency of having defaults at pod level and container level within the same limit range. Because having both of them could cause some complexity to the user if not handled correctly, and as I said before, could create more possibilities or of more combinations of creating unscalable pods. But yeah, it will not break any existing behavior. It just will extend the possibility of setting the pod level defaults, which could be handy. But yeah, the thing is that because of the way I'm thinking the feature, I think the user will handle separately. Most of the times, the user will just set pod level or container level, not with the same limit range. And in the case that they want to use both, well, they will have the possibility. But that would be just the question. And also, so we don't limit the pod level if the user want to use limit ranges with it. That could come in handy for cases where the user wants to constrain subcontainers and allow all the others to be shared within the whole pod level amount.
Again, if you have a write-up with a nice like use case explicitly stating like what people will want to achieve with that, that will be useful. And yeah, you mentioned that setting pod level and container level at the same time doesn't make a lot of sense. Maybe this is educating our use case. So use case will dictate that you need to either set this one or that one, not both. But yeah, it really should be driven by what people want to achieve with limit rangers. And again, limit ranger is not an ideal API. We shouldn't copy limit ranger for the sake of copying it. If we think that better API exists, we can entertain this idea as well. Like we don't need to just copy what it already has.
I agree. Okay, yeah, I will write a document summary for both subjects and then get back to you in the next Signal meeting. Thank you.
Okay, next one is TK.
Okay. Hello, everyone. Yeah, so I don't have any slide ready for it, but there is a KP open for this particular feature. So, okay, I'm not able to share the screen. If you can open the link, that would be fine.
You should be able to share your screen now.
Right. Yeah. So, okay, is it visible, my screen?
Yes, I can see myself.
That's right. Yeah, okay. So this is a small enhancement that has come to one of the challenge. So currently, what is happening is like basically whenever we are configuring a image mirrors for a particular container, and when we are deploying it, so we don't know the which mirror is being pulled for that container image basically. So this becomes one of the challenge when there are a lot of mirrors are configured for a particular container image, and we really don't know from which image, sorry, from which mirror that particular image has been pulled, right? So the kubelet notifies us it only when it's not able to pull the image, but other than that, we are not able to identify it directly. So we have to go through the runtime logs and go through the logs. Then only we will see, okay, it came from the mirror one or mirror two, etc. So this is a small proposal to address this challenge. So basically, like if we are moving the services into a private clusters, and we probably have to mirror some of the images, and this would come handy for the users to verify basically their containers or their pods are actually pulled from their internal image rather from the a different one. So this is the challenge and the motivation for this step. Um, so in order to address this issue, what we have come up with is like by introducing a parameter on the status field of the containers. So let me go to this one. Yeah. So on the containers as well as for the image status, we are introducing a field like image pull source. So that would basically uh, would would basically like it would be the actual source from where the image is pulled. So if there is no mirror is configured, so it would be from the direct source. If the mirror is configured, it would pick whatever the mirror the image has been pulled. So the runtime has to uh, pass over the information to the kubelet in order to no, display these details. So and we have two things. One, on the image status we would be displaying. So image status is basically useful when we are inspecting that particular image using the crctl command, and the container status is to for the containers. Yeah, so in this particular issue, I think I have, instead of the design details, maybe I'm looking for some of the reviews from you folks. So like what are the changes we need on the runtime? Um, So those details, like whenever we are pulling the image, after we pull the image, we need to pass out. We need to store the pull source in our disk. I mean, we have to persist the details so that the container restarts. Sorry, runtime restarts would be able to identify all those necessary details.
I think today, right, all the mirroring is done by the runtimes. So maybe you can add a
Yes.
section describing how the different runtimes are doing the mirroring, and if your design is going to work for all the runtimes. And maybe we need to codify what is being done, because if the runtimes diverge in how they are doing this, then this could break down.
Okay.
Um,
So okay.
I mean, I totally, the idea makes sense to me. Yes, we should be exposing the mirror from where it is pulled from. But then when you start talking about integrating it into multiple places, then that starts to worry me a bit. And I think you
Okay.
also have a statement that we shouldn't worry about the case where it's pulled by digest. Do you have a rationale for that? I'm not sure why we should do that. We should always try to
Yeah. So there are two kind of configurations. One is like the mirrors can be configured for two cases. One is for the digest pulls only, another is for the actual image pulls only. In case of digest pull, what happens is like it would just pull the digest, but eventually the actual image would come from the whatever the destined registry it is, right?
Right. So I mean, like, yes. So I mean, both options are available, digest or tags, and I'm not sure why it's a non-goal that we should not be concerned about when pulling by digest. Why is that out of scope? Is my question.
This is digest pulls for okay, I might have misunderstood the statement. I mean, what I am trying to say is like on the mirroring side, there are certain options like pull all or digest or tag only, or I think. Yeah,
Yeah,
maybe
I think you're
I'll
probably
revisit this statement
describing.
once.
Yeah.
Yes, I have
Okay.
misinterpreted this. Yeah.
Yeah,
Okay.
presume here that the digest is to the manifest, right, for the image that we've resolved.
Basically, yeah, manifest pulls actually I'm not concerned about. That's what I'm trying to say. Because I don't want, I mean, because even if you pull manifest from different source, eventually the actual image will pull it from the different source, right? So, uh, so the goal I have actually put up is like for the image only. I'm not looking for the manifest.
I guess it will be helpful if you already don't have examples, right? Maybe you can describe all the different cases when you're pulling latest, you're pulling by tag, what the mirroring setup is, and what you are saying should be handled and how it should not be handled, so we can evaluate it. Because I think, like, even like from a security perspective, when we set up mirroring, we generally want everything to be pulled by digest. So having that as
Right.
out of scope is concerning to me in this case. Sorry, I'm holding up Sergey. Sergey, if you wanna add anything.
No worries.
Okay.
Yeah.
Okay.
So a couple of comments from me is I agree with Mrunal. Listen, what kind of user scenarios you want to cover and what runtime scenarios you want to cover. Some things we main need for containerd is like which snapshotter was used to pull the image. Like it's not only about mirror, but also about like which snapshotter was used. Like if you use StarGZ versus like regular snapshotter, it may change a lot how you see this image. And also, I didn't look at it whether you addressed it. Like, do we want to preserve this information forever? Does container runtime require it now to keep this information where it was pulled from, or it can be only returned once? That may be also interesting piece of information, like piece of requirement for container runtime, like how reliable this information will be and how reliable you should expect it to be from container runtime. So if it's just information only, like I don't know, like how useful it will be, like how, yeah, that's another point. And also like this cap have some may have some commonality with another cap that was proposed is to enable authentication on mirrors. Today, all the authentication is handled by kubelet and all the mirroring is handled by runtime. And it creates a situation when you have a mirror that requires authentication, we wouldn't pass this authentication information even if you have this information. So we've been even discussing like whether we want to move all the mirroring logic to kubelet, and if we will do, this situation will come easier, and also authentication will come easier. So maybe it's even bigger things that we may start doing.
Yeah, agree. I mean, it may be worth discussing moving up mirroring entirely to kubelet. James.
Yeah. So I was just trying to understand. So what are you trying to do this so that you know exactly which image is running, or are you trying to do this because you actually need to know what source it came from? Because if you want to know which image is running, then the image pull source is not as useful, because if you're pulling by tag, that image could have changed since the pod started. It might be better in the to put the digest that was pulled.
No. The motivation is to find out the actual source from where the image has come. So especially when multiple mirrors are configured for that particular image.
So why do you only want to know that by tag and not if it's by digest?
So I may have one small example. So let me go through that. Yeah. So I made some changes on the runtime of the kubelet to just to verify this thing. So here you can see the status field, right, for the container. I agree. I have tested only with the tag. Maybe I can come up with an example just like Mrinal said with digest as well. So yeah, this is the new field that we're addressing. So here you can see this is the actual image. So I have used tag only here. So the 40 is the actual tag, and the mirror configured is for the minimal. So that's how we are trying to identify it. So the image has been pulled from this particular mirror instead of colon 40.
Yeah. But why do you need to know where it was pulled from? What is your motivation for knowing where it came from?
Yeah. So there are times what happens is like if the mirror is image is not present, well, kubelet says. But as a developer, let's say I'm trying to move certain services into the private clusters, and I have mirrored all those images. So when I'm doing the end-to-end verification, right? So it's difficult for me to log into the node and run over the runtime logs to fetch the actual image details and then verify with that one. It's not just straightforward to verify the source. So if it's there in the status field, yes, it would be a straightforward solution. So
okay, but I guess another option would be to when an image is pulled, there is an image pull event on the pod, isn't there? So to just put the data into that event instead of having to store it in the status. Would that be another option?
Okay. Yeah. Okay.
That might be easier to do than having to change the model.
So yeah, I'll look into that as well. Yes. Okay. But runtime anyways have to pass on the information to the kubelet for this, right?
Yeah.
I think we should probably get a call going to have a discussion about this a little bit. Issues like What would you do in a redirect situation? Do you want to actually know the redirect or the original logged in, right? How much? What if the image was imported? What would you like to see there? There's a lot of questions that I think we need to go over all the various scenarios.
Yes, yes, that was one of the things have been noted here. If the image has been pulled outside the like if there has been imported means definitely we cannot identify the source.
But even
Yeah.
if it was
Or if
pre-pulled,
it's been pulled by a previous pod, right?
yeah.
That's right. Any one of your layers could be cached, right? So you literally are just looking for the latest tag or a particular, image digest, a SHA reference that you're pulling. Where was that resolved against? And that could be different per user, per pod. Especially with
Sorry.
your image is, kept that is going in.
Okay.
Yeah, it's a good point about layers. They may go from different sources. So what if one registry will refer back to previous registry? Like, yeah, that is very tricky.
Okay.
And in
So
Yeah,
GKE,
because sometimes we don't really pull and we just recheck the manifest because there was a request to do that. But we may not do that if the particular pod has the users, right? The same secrets, for example. Then we won't do that anymore in the insured images process. Okay. So if you're asking for status for a particular user, and as Sergi said, for a particular runtime handler, where we in Containerd might select a different snapshot, or yeah, if it's using lazy, then it may not be fully pulled yet. What do you really mean by this? Is the type of conversation we need to have. The use cases need to be drawn out a little bit.
Which is one of the reasons I think it's probably simpler to just try and get an additional event or put some more data into the events, because it's when the image gets pulled is the only time you're going to really know the source.
Yeah, and when you say event, you're talking about registering to the internal services events for images within like the Containerd client.
No, I mean, can we get that information surfaced as a Kubernetes event in the same way that an image pullback off event happens or an image pull failure event happens?
Yeah, yes, we could. I mean, we don't yet today do any publishing of the events of the actual image services execution. You can do it, but I don't think they're registering for those events at this point.
Yeah, we do it from in GKE. We have snapshotter similar to StarGZ, and it will publish event directly to Kubernetes through kube client. It's very handy and it works like a charm. We want a better mechanism for some use cases.
Okay.
Like not
So
ideal.
you're
but-
doing a push then from the snapshot, a custom snapshot.
Yeah, so it's doable.
Oh yeah, it's definitely doable. And we actually have a way to subscribe to image events as well, Sergi, from the core client.
No, it's just an
Containerd.
event associated with the pod. So you do pod describe and you see all the events for this pod.
Yeah. Cool.
TK, great scenario. We need more details on what exactly you need and how we can achieve it. And also it interlies, like we have other caps that may be beneficial this with that, and maybe we can do a bigger refactoring of this logic. But yeah, thank you for bringing it up. Do you have a next steps? Do you understand the next steps?
No, so I have left. I'm basically I just wanted looking for the reviews only. So yeah, so I have got some good details. So I'll try to work upon the comments and I'll come up with another plan.
Yeah, please work through the comments first because you wouldn't get a lot of reviews before all those comments are addressed. And there are quite interesting comments and suggestions how to do it differently. Yeah.
Yes, agreed. Yeah. Hey, thanks everyone. Thanks.
Okay, we almost out of time, but I noticed that there is another item on the agenda. James, do you have 1 minute? Or we
This
can
is-
do it the next time.
This is procedural, really. I've had a PR open for a while that hasn't had any reviewers. Is there something I can do or somewhere I can go to request a reviewer for it? I don't know. Is there just a big backlog? I don't know the process.
You did the right thing. Thank you for bringing it up. Yeah, it already gets some reviews, right? So
Yeah, it has some reviews, and then so I fixed all those comments and it's ready to go again. But I don't know how to get more.
okay. Yeah, if any reviewers on the call, please review and LGTM, so it will be picked up. Thank you.
Cool. Thank you.
Okay, with that, we're out of time. Thank you, everybody. See you next week.